Well, hello PreAlgebra. Welcome to another week. This week, we're going to be looking at the distributive property. So, in order to really understand the distributive property, we first need to really understand multiplication, and we need to understand what it means to distribute something. So, in a larger sense, businesses and other places have distributors, and a distributor takes their product or their item and it gives that product or item to everyone else. And so that's what a distribution center does, is it collects the products and items and it sends them to other places. And so the distributive property uses that same word intentionally. It has the same meaning here, where we're giving something to everything else. And so let's go ahead and look at multiplication first and build into where that distribution really plays into effect. So first we're going to start with 2 times 3x. We've already discussed that when you multiply, you are repeatedly adding. So when I have 2 times 3x, what I'm really saying is that I have 3x twice being added together. So overall, if I have 3 x's and then I gain 3 more x's, I have 6 x's. And so 2 times 3 is 6. Now, we can represent that with the dot, or we can represent that with parentheses. 2 times 3x. And we get to the same thing, 6x. This example and the previous one have worked because the 3 and the x are being multiplied together. So x is acting like a label. We're talking about the number of x's we have because we're continuing that multiplication, which is repeated addition, both here with the parentheses and up above with the multiplication point. Now, let's look at a layer where they're not being multiplied. Let's say we have 2 being multiplied by 3 plus x instead. Notice on how that changes our problem completely. We no longer have 3 x's. We now have 1 x and 3 of something else. So we have 3 of something else, we have 1 x, 3 of something else, 1 x. What is the 2 doing? Well, the 2 is still doubling what we have. We just happen to have 3 of one thing and 1 x. We just now have that twice. 3 of one thing and 1 x. We still have 2 of them. It's just that now we're talking about 2 different things. And so we can still, from here, combine our like terms and simplify what we have. We just have to approach it that intentionally because we're talking about x's and then something else. And so let's go ahead and do that. We don't need the parentheses anymore because we don't need to group them anymore. There's nothing else that's being multiplied. So this is the same thing as just saying 3 plus x plus 3 plus x. And so we have 2 sets of 3. 3 plus 3 is 6. And we have 2 x's. And so x plus x is just that, 2 x's. And so when you go to simplify that, 2 times the parentheses, the quantity of 3 plus x, is 6x plus 2. Now, let me show you another way to do that problem. Because this works, and this is the understanding behind the problem. But there's an easier, quicker way that you'll see your algebra teachers do this in the future. And so that's where the distribution property comes in. That's where the distribution property comes in. Notice that 2 times 3 plus x, the 3 and the x here, are both doubled. And that makes sense because we have 2 of them. But if we have 2 times 3 plus x, that's not plus, 3 plus x, what we can do instead is actually multiply by that 2 to everything in our parentheses. And so that 2 is getting multiplied by 3, and that 2 is getting multiplied by x. So rather than write it as addition, we can distribute that 2 and do that multiplication individually to both the 3 and the x inside. And so we do the 2 times 3 first. 2 times 3 is 6. And then the 2 times x, which is just 2x's. So just like the last problem, we get the exact same answer, but the steps look different because we're doing that multiplication through that distribution. We're distributing the 2. We're giving that 2 to the 3 and the x because it's being multiplied. So let's take a look at another example here. There it goes. Made it. Perfect. So let's take a look at another example here. In this example, let's go and switch up some of the numbers. Let's go ahead and say we have 5 times 4 minus 2x. And so we have the parentheses there. We're multiplying by 5. We know we're multiplying by 5 because there's no symbol between the 5 and the parenthesis. So that means we can distribute that 5 to multiply by 4 and distribute the 5 to multiply by 2x. And so that means we have 5 times 4. 5 times 4 is 20. Then we have 5 times our negative 2x. So careful with that negative here. We're not adding and subtracting. We're multiplying by 5. And so 5 times negative 2 is the same thing as 5 times 2, which is 10. Then a positive times a negative, which is a negative. And so 5 times negative 2x is negative 10x. Let's go ahead and take an example where that negative is outside of the parentheses. So rather than a positive 5 like we had before, let's make it a negative 5. So we have negative 5, and I'll change the numbers inside as well. 8 plus 3x. So negative 5 times 8, and then negative 5 times 3x, because we're still going to distribute because we're still multiplying between the 5 and the parenthesis because there's no symbol written, and there's the addition happening within our parentheses, addition or subtraction, as we had subtraction up here in the previous example. So negative 5 times 8, well, is the same thing as 5 times 8. And in calculator geniuses, 5 times 8 is 40. And then a negative times a positive is a negative. Then do the negative 5 times 3x. Negative 5 times 3 is 15. Negative times a positive is a negative. So negative 5 times 3x is negative 15x. So notice our answer had both the 40 and the 15 negative, and the reason why we were able to get that is because both the 8 and the 3 are positive. And a negative times a positive is a negative. And that 5, the negative 5 is being multiplied by both the 8 and the 3. It's being distributed to everything inside the parentheses. And that's the hardest part about the distributive property, is remembering that it actually gets multiplied by everything. So one last example. Let's do negative 2 times 4x minus 3. The x can go either in the front or in the back. Either way is going to work out just fine for your problems. This particular example has the x in front, so we're going to multiply the negative 2 times the 4x and multiply the negative 2 times the negative 3. I'm drawing the arrows over to help me keep track of what I've multiplied and what I need to multiply. So that's why I draw the arrows on top. It's not actual mathematical notation. It is just an easy way to keep track of what's being multiplied. And so negative 2 times 4 is the same thing as 2 times 4. 2 times 4 is 8. So negative times a positive is a negative, and negative 2 times 4x is negative 8x. We have negative 8x's there. Next, we have the negative 2 times negative 3. Negative 2 times negative 3. Well, 2 times 3 is 6. We can take care of our numbers first. Then we have a negative times a negative. And when we're multiplying, that's when two negatives make a positive. And so negative 8x plus 6 is the result we were looking for. Thank you, guys. I hope that helps. Don't hesitate to email me if you come across any questions that you don't know how to answer. I'll be more than glad to help. I look forward to seeing you guys on Wednesday. Hope you have a great week.